Hello and welcome to CPB 324, Chemical and Bioengineering Computation Statistics. My name is Professor Pluch, and I will be your instructor. I will be your coach for the duration of the semester. Over the course of the semester, I very much look forward to getting to know all of you and working with you to help you master the course material. So with that, I will emphasize that my goal is to help you master the course material. So if there's anything I can do, anything at all during the course of the semester to help you better master the material, please, by all means, let me know. I want nothing more than for you to be successful. Since being at Miami, since fall of 2013, I've had the great pleasure of teaching a total of 7 different chemical engineering and bioengineering courses, including this one. In addition to 324, I have taught thermodynamics 1 and 2, mass transfer, fluid mechanics, chemical kinetics and reactor design, and chemical engineering and process design. Having taught those courses, I view 324 as being a much different class. 324 is focused on problem solving. Specifically, you might think of it as problem solving with modern computational tools. Specifically for this course, we'll work with MATLAB. So my ultimate goal is that by the time you graduate from this course, you will be proficient in MATLAB so that you can use it, apply it, leverage it in your other courses to be more successful, and to be able to apply it in your future careers to solve real, authentic chemical engineering design problems. So this is a course more about problem solving, more about doing, rather than cramming a large amount of content in your head. And with that, you will find that the setup is much different than your other courses. It's more of a problem-solving class. Rather than exams, we will have problem sets that will constitute the major component of your grade. I have tried to do everything I can to make the material as accessible as possible, including creating the textbook for this class, and I'm actively developing a YouTube channel with screencasts that include me solving example problems and tips and trying to clarify via screencasts typically confusing points from the previous semesters that I've taught this class. So again, my goal is that by the end of the semester, you will be proficient in MATLAB to be able to apply MATLAB and solve problems in your other courses. And additionally, not only be able to solve authentic problems, but to help gain an appreciation for MATLAB and physical modeling altogether, to help use it as a tool to better improve your understanding of material in those future classes. And what I mean by that is, so say if you're taking a class in kinetics and reactor design, you could read all about the theory, about how to optimize a batch reactor when you have series and parallel reactions going on. And that's all great and dandy, but we could also just as well set up a model in MATLAB and tweak parameters and see the effect of selectivity and conversion and things of that nature, and optimize a reactor just by turning knobs, tweaking variables, and seeing what the effect is. And so hopefully at the end of this course, you'll also gain an appreciation for physical modeling altogether, and get an idea of how you might use it in your future classes to better master the course material. So what I will do here in a second is I will turn off my webcam, and then we'll go and we'll have a look at the course Canvas page. We'll navigate the course Canvas page and see how we can get around there. We'll take a look at the syllabus together, and then we will also take a look at the course text and how you can link to external resources from there. So I will pause this, eliminate my webcam in a second, and then continue on with my full screen available. Okay, so I've turned off my webcam, and here I am on the main page of our course Canvas page, and I am in student view, so I am seeing what you'll see when you enter the Canvas environment. Okay, so this is our home page, but the first thing I'm going to look at is the syllabus. Okay, so this is a plain old syllabus page which summarizes the main features of the syllabus. The official syllabus, the official contract that will follow in this course can be found in the PDF, which can be downloaded here, and we'll link to it elsewhere. Okay. I'm going to click on it and open it up in another tab in Chrome. Okay. And so it's a standard syllabus. If you've taken classes with me before, it should look very similar. Okay, but what I'm going to scroll down to is grading and the point breakdown. So there are a total of 1,000 possible points in this class. And as I mentioned previously, this class is a class focused on problem solving more so than learning some breadth of content like you may have experienced in your other classes. So the point breakdown or the assessments will consist of reading quizzes. There will be a total of 13 chapters that we will cover in this text. For each chapter, there will be a short reading quiz, typically true-false, fill in the blank, or multiple choice style problems. Then at the end of each chapter, except chapter 1, there'll be a problem set that you will complete and turn in for grading. And then the last part of it are what I call challenge problem sets. And so what this mainly is it'll be more of an applied engineering problem that'll ask you to solve using the skills that you've learned up to that point in the course. So for example, after we've learned how to solve systems of differential equations, we will analyze try and analyze, optimize batch reactor, and evaluate how we might optimize when we have series and parallel reactions, where we'll be required to solve a system of differential equations. Chemical kinetics and reactor design isn't a prerequisite for this class. I will help you set up the relevant physical models. But the idea is you will have the skills where once you know how to write down the appropriate mass balances, you can set up design equations for a batch reactor, turn knobs, and see what causes and effects are. Okay, and so there'll be 4 challenge problem sets along with your standard end of chapter problems and reading quizzes. So I emphasize this is more a class about doing. Okay, so if you work hard and you work through the material, my hope is that everybody will do extremely well in the class. Okay, the key will be keeping up with the pace of the course. And so you can read the syllabus in greater detail in your own time. Okay, but what I will also point out on this last page is I have a suggested setup of how you might tackle the course material in our shortened J-term semester. So as I mentioned, there are 13 chapters in this text. So those 13 chapters are what I can comfortably cover in a face-to-face class during fall and spring semester. And so the way the course is set up is, in theory, in CPB 102, you should have been exposed to MATLAB. What I have found since teaching this class in spring of 2017 is that most students enter the class with little to no MATLAB experience or little to no experience with programming altogether. So the first block, I would say, would consist of chapters 1 through 6. Okay? So chapters 1 through 6 are going to give you an introduction to MATLAB, and it's a very basic introduction to computer programming. Computer programming in the context of MATLAB. And so in an ideal world, I would strive to complete chapters 1 through 5 in week 1. Then in week 2, so there's chapter 6. So again, the last kind of chapter that's related to this introduction to MATLAB, introduction to programming material. And in chapters 1 through 6, you'll see you have a reading quiz and then your chapter problem set, so your standard end of chapter problem. Then after we've learned the MATLAB basics, we'll move in to leveraging some of MATLAB's advanced features to solve some interesting problems. So the first tool we'll look at is how to find roots of equation, or what I title here zero finding. So in chapter 7, we'll look at solving roots of an equation. And then in chapter 8, we'll build off of chapter 7 and we'll learn how to solve systems of equations. Okay, so 7 and 8 will be our first real problem-solving type of chapters. By problem-solving, I mean solving, complicated engineering problems. And so in addition to the quiz and chapter problem set, there'll be one of these challenge problem sets associated with those two chapters. So while in week 1 I say, hey, complete 5 chapters, week 2 I say complete 3, that's because you should set aside extra time to solve these challenge problem sets. Then in week 3, so where we'll move from solving roots of equations and systems of equations is tackling initial value ordinary differential equations. So we'll start out by just solving initial value ODEs, and so there'll be a quiz and chapter problem set there. But then we'll look at how to solve systems of initial value ODEs. So those would be initial first order ODEs in chapter 9 and 10, first order initial value. Then in chapter 11, we'll look at how you can solve higher order initial value ODEs. So specifically in chapter 11, we'll look at second order, although it's applicable to higher order cases. So like the previous week, my suggestion will be to cover 3 chapters, 9, 10, and 11, which are all closely related. Chapter 10 and 11 will each have a challenge problem set associated with them. And then the few days we have in week 4 to wrap things up, there's a very short chapter on interpolation, and then chapter 13, fun with tabulated data, is just a fun application of chapter 12. Okay, so chapter 12 and 13 should be relatively short and straightforward. The material isn't too much, but I've added them, and we talk about them in class because they're interesting and useful skills. So I can't cover everything in this course, but my hope is that in teaching the material in chapters 7 through 11, that you will have the skills necessary to look through the MATLAB documentation to learn other skills, to solve other problems, or to leverage the other materials available within MATLAB. Okay. So with that, I am going to go back to the course Canvas page, and we will look at how we can navigate around. So I'm going to go back to the home page, and the home page contains a basic outline of the course. Okay, so there's module 0, kind of getting started, and then modules 1 through 13. Okay, so I'll apologize for any confusion. Module is the jargon used by Canvas. In writing the course textbook, I still like to use chapters in the traditional textbook fashion. So in this course and how the course is set up, the module is equivalent to a chapter. So module 12 is chapter 12. So the homepage is set up with an outline of the course. And for chapters 1 through 13, we'll summarize the main learning objectives for the chapter, along with the items that need to be completed in the class, or in that module. And what I mean by that is, if you start in module 0, and we'll take a look at the module in a second. So the header is the link to the appropriate module. Okay, and we'll click on that in a second. Then within module 0, I need to read the Student Starts Here first step page, and I need to contribute to the student discussion board before module 1 is unlocked. Once module 1 is unlocked, I need to complete the chapter reading and complete the reading quiz before chapter 2 is unlocked, and so on and so forth. So you need to complete the module sequentially, and you need to complete a module before the next module is unlocked. Okay, so in terms of navigating around, okay, you will see a module tab over here. But if I were to click on module 0, it's going to link me to that module page and the content within the module. Okay, so in module 0, getting started, I need to read this Student Start Here at First Steps, as was noted in the outline, and contribute to the online discussion board. Once I complete those, then module 1 will be unlocked, starting with the chapter 1 reading and then the reading quiz. Okay, so I'll we'll take a look at a couple of these resources up top, and then we'll go and we'll look at the text so you have an idea of what to expect. Okay, so you can read through Student Starts here. Just has, again, some more background material. Okay. But if I go back via the module tab, I'll get back to that module link. And you'll see, even though I just quickly did that, there's a check mark that I completed it. Try and read it a little more thoroughly. So the other assignment you're asked to complete is this Introduce Yourself student discussion forum. Okay. So I have essentially no experience teaching classes online. I've only taught this class in person. So even though this class is only taught or is being taught online this semester, I still want you to feel comfortable helping each other. So again, this is a course more about problem solving. Okay, there are no exams. It's more about solving problems. So if you should be comfortable helping your classmates. You should be, I would encourage you to form in-person study groups or maybe electronic or virtual study groups where you can help each other as you work through the material. So working in a group is often beneficial because you are all going through the same experience at the same time. Okay? Once someone in a group has mastered the material, it's usually much easier for them to explain the material at a level that they can understand, that although I will try my very best, they may be admittedly more clear. So in this Introduce Yourself discussion board, all I want you to do is post, tell everybody who you are, anything you want about you, and then maybe you can find, or discover there's someone in the class that you know, someone with other interests, someone who's on campus, or maybe in your same city so you can meet up at a coffee house. Maybe try and identify and find some colleagues that you might be able to work with. Okay, and so in order to move on to Module 1, you need to just make a post. Okay, so this is ungraded, it's worth 0 points. The instructions say make a post and reply. But again, the purpose of this is just to encourage you to form a network within the class. Okay. So it's not complete because I haven't made the post yet. Okay, and so the other modules are still locked. Okay, but with that, I'm going to pause for a second and I'm going to take a look at the course text so I can point out some of the important features of the course textbook. So I want to just spend a few minutes and wrap up this introductory video by just taking a look at the course textbook. So the course text for this class is written by me. Okay. So in evaluating textbooks for this class, it was hard to find anything suitable or appropriate for this class. So appropriate in that most MATLAB books out there seem to expect that the students in the class had some prior programming experience. Most students in this class didn't. And also just being applicable to the courses that you'll take. And so the course textbook is created by me. And so if there's anything at all that I can add to help you, by all means, let me know. So what I want to take a look at is, this is just a shortened version with just chapters 1 and 2, but look at some of the hyperlinking that I use throughout the text and how you can use that to its fullest potential. So I will point out that I am viewing this PDF with Document Viewer in Linux. So the presentation may be slightly different on your computer. What's nice about a PDF is, PDF I create here on my computer will be the same on yours. The only differences that may occur is colors may be used in identifying hyperlinks and things of that nature. Okay, and so what I want to point out is, okay, if I look at even say the preface, the front material, okay, I use hyperlinking throughout. So one website I link to a lot is Wikipedia. So when I link to an external HTML, so a word that's circled in a cyan box indicates that it's a link to a external website. So if I were to click on Wikipedia, right, I come back up to my Chrome browser up here, right? Look, Wikipedia is opened. Okay. So if I return back to the textbook, I have a YouTube channel I'm developing for the text. Okay. So when I first mentioned my YouTube channel, it also hyperlinks to that actual page. Right? It opens up in another tab in Chrome. Okay. Excellent. Okay. A little too far. Okay. So that's Cheyenne boxes. Okay. I also hyperlink to other material within the text extensively. So in the table of contents, you'll see words circled in red. A red box means it's a hyperlink to material within the text. So if I want to go to, say, section 1.7 on errors, right, it's hyperlinked, I click on it, it brings me right to section 1.7. Okay, excellent. You'll also see over here on the right, if I view an outline of the text, what that means is I have tagged each chapter. Then within each chapter, I've tagged each section of that chapter. So in Acrobat Reader, you should also be able to get an outline mode, and that can allow you to quickly navigate among the material. Here I just went to section 1.11 on chemical engineering examples, and you'll even see I reference equation 1.2, right? It's right there, but if I were to click on it, right, at the top of my screen would be 1.2. Okay. So the text is set up to look pretty so that you could print it and have a nice looking book. But I would encourage you to use the digital copy as much as possible. I would also encourage you not to view it within Chrome, but rather to download it to your desktop. What I find is when I view PDFs in Chrome, oftentimes hyperlinks don't get any sort of special treatment, right? There aren't these colored boxes, or they're not underlined in a color. There's nothing to indicate that it's a hyperlink. Okay. I try and hyperlink extensively throughout. Okay. So I will link to other resources available, right? So this isn't an all-inclusive textbook, but I will link to, say, the online MATLAB documentation, which will always be available to you, and encourage you to leverage it throughout the course. Okay. In the preface, I even encourage you to leverage all of the free material available or provided by MATLAB. Okay. When I first introduced scripts in Chapter 2, right, so script is highlighted in bold because it's going to appear in the glossary at the end of the text, but then I also link to the online page in the documentation, which you can see for further details about scripts and learn other material that is beyond the scope of this course. And I will try and encourage you throughout the course to reference the documentation so that when you need to use some functionality that we don't cover in the text, that you'll be comfortable navigating the documentation, and hopefully you have the skill sets from this class to be able to read through the documentation, follow the examples, and actually use said methods. Okay. So the other thing that I will point out is I mentioned I have a YouTube channel. Okay, and so where that comes in is within the scripts chapter on page 24, a common point of confusion in previous semesters is your MATLAB path and the directory that you're saving files in it. And so while I've tried my best to write in the text, to explain how these things work, you may be a visual learner, and so I have a screencast on the YouTube channel. Or if I click on it, okay, I'll pause this.
So whenever I teach students,
right. So if you click on it, it'll bring you to my YouTube channel where I have a screencast of me trying to walk through that concept. Okay. So return to the book. Okay. So that's one example where I linked to screencast. Additionally, there are example problems throughout the text. So I have screencasts for select example problems in which I work through the solution. And so what you'll see is here's the problem statement. So here's example 2.4. Oops, because my cursor's over here. So here's the problem statement. And see, I'm even linking back to chapter 1. And this will come up a lot. The text is set up so that we solve a problem, and then the next chapter we often solve it again with a new skill that we learn to make this problem or the solution simpler and easier. But here's the problem statement, and I provide you with numerical answers so you can get an idea if your code's working right. And the intention of this is you get the problem statement, then you can try and solve the problem. You know what the final answer is and see how you do. After you solve the problem, first you'll see I have a written typed up solution, okay, where I'll walk through my solution. And then beginning in chapter 2, once we learn how to create M files, you'll see in these listing environments a copy of the code that I wrote. Okay, and then this would be my interaction in a terminal. So what you'll notice is in that heading, the name here, so this is the name of my M file, it's circled in a Cheyenne box, right? So that indicates it's a link to a website. Okay, and so what I've done is this is displaying a copy of my M file. I have also put a copy of my M file in my Google Drive account so that you can link to it and you can download a copy of your own right there to your desktop. So I try and link all these files within the text. I don't provide them in Canvas. Okay. The reason being, I've done this in previous semesters, is when the semester ends, you're locked out of the Canvas page, and so then you're left with just a PDF, and you don't have access to these files unless you downloaded them. And then they're a pain in the neck to keep with the text if you ever wanted that actual text document. And so what I've instead done is I've tried to create this text so it's your one-stop shop. You graduate from the class, you have a copy of the PDF, and then you have these links that work to external resources that you can download to better help you learn the material. Okay, so 10 years from now, if you want to brush up on your MATLAB, you can send me an email. I can send you the PDF of the text, and then with that single document, you can link to everything out there that's available. Okay, so that's next to the listing name. Okay. What you'll also find is for select problems, for most of the examples, is following the solution header, you'll see a link to screencasts with accompanying M files. Okay, and so what this means is there's a screencast available. If I click on it, it's a screencast of me solving the problem. Okay, so I'm going to pause it so you don't hear me talking. But when I solve the problem, it is me authentically or genuinely solving the problem there on the spot. It's me looking at the problem statement and then working through the solution. And I mention that because what you may find is my solution in the screencast may differ slightly from the solution that's presented in the text. The reason for that is, again, this is just me sitting down with the prompt and solving the problem live. And so, since the solution may differ, if you look at the description posted on YouTube, I will provide a link to the M files I create in the screencast. Okay, so if I scroll ahead a little bit, I'm creating a file AntoinePCalc.m. Right, and so I believe that's this first file here. I click on it, a link to my Google Drive where I can download AntoinePCalc.m. And so this version of the AntoineCalc.p.m is the exact file that I wrote in the screencast. Okay, so that may differ from the solution provided in the text. I haven't forced them to be the same with the initial thought of it gives you another example to look at. Okay, so You can see a screencast along with my M files that I create in the screencast will be available for download, and then the M files will be available for download throughout. Okay, so when you see hyperlinking, try and take advantage of it. There are either going to be screencasts or copies of my M files to help you as you work through the material, or again, the focus of this class is on problem solving, so I don't go into great details and numerical methods. That's still interesting and important, and so I'll provide links to external resources to gain more information on said topic. I'll also link extensively to MATLAB's online documentation, so you can learn in greater depth on topics, and also just to get comfortable looking at the documentation to help you learn material outside this course. Okay, so with that, I will wrap up this introductory video, and if there is anything at all you need, by all means let me know. If there is something that's unclear from this video and you want me to create a screencast going into more detail, let me know. If you want to do a Google Hangout with screen sharing, let me know. Okay. Again, I look forward to working with you and getting to know you better over this semester, and will do whatever I can to help you out.